Hello. So in this class we are going to solve a problem on principal stresses. Okay, so the problem is on your screen. So the problem is find the location and magnitude of in-plane major and minor principal stresses, and also sketch the state of stress on the principal plane. Okay, so we have to find the location of the plane. Basically we have to find the location of the principal plane first. Okay, and we can find that using tangent of 2 theta p is equal to tau xy divided by sigma x minus sigma y divided by 2. It will give you us it will give us the values of theta p, right? And we will get two values of theta p, and those are the location of the principal planes. Okay, and then we have to find the magnitude of the major and minor principal stresses. Right now we can use the formula of the major principal stress, like sigma x plus sigma y divided by 2 plus square root of, right, sigma x minus sigma y divided by 2 whole square plus tau xy whole square, right? We can use this formula, but what is the problem here? If we find the stresses using this, then we will not know which stress belongs to what plane, right? This thing have a problem. Okay, so if the question was simple that we only need to find the major and minor principal, then we would use first the plus sign and then we would use the minus sign, right? Then we would get the major principal stress, that is sigma 1, right, or minimum principal stress. By the way, minimum principal stress or minor principal stress, they are one and the same thing, right? And then we would use the minus sign to find the minor principal stress or the minimum principal stress, right? So this one is the major, which corresponding to plus sign. Okay, but the problem here is, again, we wouldn't know that which stress belong to which plane, right? We would get two values and that's it. So instead of using this formula, we will use the basic standard formula of finding the stresses on an oblique or transformed plane, right? Sigma x prime is equal to sigma x plus sigma y divided by 2, right, plus sigma x minus sigma y divided by 2 cosine of 2 theta plus tau xy sine of 2 theta. Okay, so whatever we will get here, two values, right? We will get two values. We will substitute one theta p here, right, and then another theta p here. Because we use this theta p, so it is not going to be sigma x prime, it is going to be sigma prime. Okay, then based on which is maximum stress and which is minimum stress, right, we will say what is the major principal stress and what is the minor principal stress. Okay, so we will do these things one by one. Okay, so let us first find the the location of the principal planes. Okay, so it is, now if we consider this side as positive and this side as positive y-axis and this side as positive x-axis, on the bright side, right, that is on this side and this side, then from this we will understand what is the value of sigma x. Sigma x is this one, right? It is opposite to this, right? So it is minus 20 megapascal, right? Then we have sigma y. Sigma y is this, which is towards this, right? So it is positive. Sigma y is 90 megapascal. And tau xy, what is the value of tau xy? Tau xy is this, right? It is in this direction, so it is positive, right? We can also find it using this arrow, right? It is in the same direction as that of the x-axis. Okay, so again it is positive, so tau xy is positive 60 megapascal, right? 60, okay, megapascal, of course, everything is megapascal. Okay, now I think we are good to find the value of the theta p. Okay, so let me use a calculator. Tangent of 2 times x is equal to tau xy, which is 60, divided by sigma x minus sigma y divided by 2. Sigma x is minus 20 and minus 90, right, divided by 2. So we got two angles. Yes, we got two angles here. So we got, first we got is minus 23.7, approximately 7 degree, okay, and the other angle that we got is 66.25 degrees, okay. So we got two angles, okay. So these are our location of principal planes, okay. Now we don't know which is the major principal plane, and we don't know yet which is the minor principal plane, okay, because we have to find the stresses, okay. So I will find the stresses one by one. Okay, now for theta p equals, let us use this angle first, 23.7 degrees, okay. For theta p equal to this, we will find this, this stress, right? We will find the sigma p, okay. So it is, so let me just use the calculator, okay. So it is sigma x plus sigma y by 2, it is minus 20 plus 90 divided by 2, right? Then we have plus sigma x minus sigma y by 2, minus 20 minus 90 divided by 2 times cosine of 2 times theta, okay. So it is, but theta is negative, so it is minus 2 times 23.7, right, because theta is minus 23.7, okay. Then plus tau xy. What is the value of tau xy? Tau xy is 60 megapascal. 60 times sine of 2 times, again it is negative, okay. So minus 2 times 23.7, okay. So I got the value of negative 46.4 megapascal approximately, okay. So right now I don't know if this is a major stress, if it is major principal stress or minor principal stress. Why I don't know? Because I have to find both the values of principal stresses, and whichever is the maximum will be the major, and whichever is the minimum will be the minor, okay. So first we have to find the both and then compare, okay. So let us find for theta p equal to, which is another angle, is this, right, 66.25 degrees, okay. So what is going to be the sigma p? So the formula is same, so here theta p is going to be 66.25 and 66.25, okay. So I have already typed the formula in my calculator, so I will only change the values. 2 times 66.25, and I will also change this to 2 times 66.25, okay. So I got approximately 116.4 megapascal, okay. Now I can say which is major and which is minor, okay. So you can see this is minus 46 and this is 116, okay. So clearly this thing is the major principal stress, okay. So I will write it as sigma p1, because 1 is for major or maximum, okay, and this theta p is now theta p1, right. Similarly I will call this as theta p2, because this is the minor principal plane, and this stress is the sigma p2, okay. So what was the question? And the question was to find the principal stresses, major and minor, right. Now the other part of this question is to sketch the state of stress on the principal planes, right, because we have two principal planes, okay. So let us do it. So so this is our this is the before one, right? This is before rotation, right? This, let us say this is before rotation. Okay, now I will draw the after rotation. Okay, now what is the angle? We have to get any angle. Let us get this one. Theta P2 is minus 23.7 degrees. Okay, so it means negative means clockwise. Okay, so when I rotate this thing by 23.7 clockwise, okay, so this is what we get. Okay, so this is 23.7 degrees. Okay, so the good thing about these principal stresses is now you don't have to calculate this value. Okay, then you don't have to draw this 66.25 because we know from the basics, concepts, the principal planes, right? The principal planes, they are perpendicular to each other. Okay, the principal planes are perpendicular to each other, and you can see this right here. This thing, this one, right? This one is already perpendicular to this, right? So we just have to write this angle. Okay, so we don't have to do much. Like this angle is 66.25. okay, so it means this is the angle. Okay, 66.25 degrees, right? 66.25 degrees, right? Now this one is what? This one is the major principal. This thing is the major, this plane, and this one is the minor. Okay, so if I draw the rotated body on this like this, okay, so we have to draw it like this. Okay, now at this 23.7, what is the value? 23.7 sigma P2 is negative. Negative means compression, right? It means opposite to the coordinate axis. So in this is our x prime, and this is our y prime. Okay, so if we draw in this direction, it is going to be positive. If we draw in this direction, it is going to be positive. Okay, but we have a negative value, right? Minus 46.2, where at this angle, right? Minus 46.4, right? So it is at this, right? So it is not like this, it is basically like this, right? So it is basically like this. Okay, so its value is 46.4. okay, 46.4 megapascal. Now this thing is at an angle of 66.2 degree, right? And here the stress is 116, and it is positive, means in this direction. Okay, 116.4 megapascal. Okay, now if you wish, you can also draw their complementary parts. Okay, so this is 46.4 megapascal. This is the complementary stress of this, right? And here we have the complementary stress of 160.4 megapascal. If you wish to write this. Okay, now we don't have to draw the shear stress because we know the shear stress on the principal planes is 0. Okay, so this saves our bit of time. Okay, so this is the final answer, and this is our sketch of the principal planes along with the principal stresses. Okay, so I hope you got this. Okay, now what is more important is here is the homework problem. Okay, now this thing you have to focus on this. This is your homework problem. Okay, so you can if you are watching this video lecture, you can grab your pen and paper and begin, and you have to find the correct option, A, B, or C. Okay, so to save your time, I will let you know that correct option is option B. Okay, so your job right now is to find the to compare your answer and make sure you are also getting the option B as correct option. Okay, so just try to solve this problem. Okay, and I will provide the solution in the next class. Okay, so if you have any doubts, you can comment or you can also contact me. And that's it for this class. See you in the next class. Thank you.